Hey everybody, I wanted to take the time today to show you the dedicated spinning station box and headstock tailstock that I've designed for, well, specifically for my Q-Demon CNC XL milling machine. Now this gives you the addition of adding a spinning station to the machine, so you can do tapering, profile, butt tapers, shaft profiles, uh, theoretically turning stock from square to round, and cutting ring billets, things like that. Now, the reason that I designed this is because with the standard or any standard 4-axis CNC machine, you cannot have the fourth axis running continuously in one direction. Stepper motors just aren't specifically designed to do that, nor can post processors like Mach 3. They don't have the capability of running the fourth axis independently of your G code. So what I did is I created this box here. It's a dedicated controller, and it has its own driver inside for that one axis, and it has its own power supply dedicated, and it has a digital readout, and it has its own internal components to operate that headstock without the need of a computer, which also means without the need of Mach 3. So as you see, there's no computer here. It's simply just plugged in, and I'm going to give you a demonstration. Now this one has, this is a NEMA 17 stepper motor, and it is designed, or I have rather designed it, to run continuously in one direction, via whether it be clockwise or counterclockwise. Now, you'll hear a lot of times, or rather, you'll hear the argument that stepper motors are not designed to run continuously in one direction. Well, no, they're not designed to run continuously in one direction. However, they can, and they can do it with great precision and reliability. As long as, this is the rule of the stepper motor, as long as the stepper motor itself is not exceeding the rated temperature for that particular stepper motor, you can run it in one direction eternally, forever. And most stepper motors, I'd say 95 to 97% of all stepper motors, are rated for a temperature of 170 degrees Fahrenheit. Now, the way that I have this box designed is it never lets that NEMA 17 here exceed 94 degrees, which is well under the rated 170. So what I'll do, I'm going to give you just, I'm going to spin the box around to show you the back of it too, but I'm going to give you a little demonstration of how it works, and then you can decide what you could use it for. Again, I designed it for an accessory, or rather an add-on for our CNC machines, so you could have a spinning station. Now, in the front, you have your power button, and then you have your controller. On the controller, you have a button that says, that'll make you go clockwise, one that makes you go counterclockwise. Underneath here, I don't know if you can see it, but you have a run stop to stop either one of those. But you can also just click the button to make it stop too. You have a potentiometer that you can turn to change the RPM. As you turn it, the RPM's readout here goes up or down, and it's very precise. If you put it on 60, and I test every one of these, and I do so by dialing it up to 60 RPM and then simply using a stopwatch, pressing them both at the same time, and seeing or verifying that it does rotate 60 times inside of 1 minute. So that verifies that the RPM is correct. Now, on the back of this box, it's very simple. On the back of the box, you'll notice that I have the power, and I have a DB4 input that runs from the driver to the stepper motor. Now, what I'll do is give you a couple specs on the head unit, or the dividing head. Now, this one is 65 millimeters from, let me get a pointer out, is 65 millimeters from the bottom to the center, okay? And it has a 2¼ inch chuck head on it. So you can actually chuck material up to 1.9 inches in diameter. Now, I would recommend not running it more than about 350 RPM. And you know, if you're doing this properly in the Q world, you're never going to run it 350 anyway. You're probably never ever going to, or rather you shouldn't ever exceed about 250 RPM at the most. For example, if you're tapering a bud or you're profiling a shaft, you're going to want to run it about 160, between 160 to 180 at the most. So this is more than sufficient to accommodate that, and the torque is there. Let's turn this thing on. So when you turn the power on, you'll notice that the digital readout comes up, and it has your, again, it has your clockwise and your counterclockwise. And you can set each one of these independently. For example, if I hit the clockwise, let's go ahead and do that. You'll notice I have a black line right here. Well, I have the clockwise set at 25 RPM. And now you can see it spinning, and it is spinning at 25 revolutions per minute. And as far as torque, I can grab this, and I'm squeezing it really hard right now, and it is not stopping. So the torque is there. And to stop it, you can either press counterclockwise again, and it turns it off, or you can press run stop, and it turns it off. Now, on the counterclockwise, I have it set for, I think it's 250 or 350. I have it set for 350. Now you notice, I mean, that's a lot faster. It's nice and quiet. It's smooth. And again, that torque is there. I'm not stopping it with my hand. And you can change these. Let's turn this off. Let's go back to the 25, and I'll show you how to increase it. Again, I have it set at 25 RPM. You can take the potentiometer. Let's turn it up to 50. And that's 50 RPM. Let's go to 100. That's 100 RPM. Let's go to 200. That's 200 RPM. Let's go to 250. That's 250 RPM. And let's go to 300. That's 300 RPM. Let's go to 350 RPM. That's 350 RPM. Now, you can adjust this, like right now it's at 350 RPM. I can turn it down and like 300, I can turn it down 1 RPM per click. So now it's 349, 348, 347, 346, 345, and so forth. Excuse me. Now, again, I would never recommend running it more than 350. Typically, like I said, you're going to run it about 170 to 200. Well, I'd say between 150 and 200 at all times. Now, this can also be used if you wanted to design and build a clear coating station. because of the fact you can have it running all the way down to 25 RPM. That's an ideal speed for clear coating. Now, I have not done that yet, but it'd be very simple. You know, it's just make a plate 30 inches in distance and put your cue on it. Now, let's see. There's 25 RPM, and that is the perfect speed for a clear coat. Now, a couple things that uh, I'd like to inform you of is that if you have it at a high RPM, then let's see. Well, let's just put it. Say it's at 350. Let's put it overboard. Let's go 400. All right. Now I stop it, and then I start it again. It locks up, and the reason that it locks up, see, is because it's asking it to go too fast initially. You have a torque curve, and what you want to do is whenever you run this, you want to start it at a lower RPM and then simply just turn it up, uh, giving it time to not miss steps. But like right now, I have it set at, let's see, 325. Okay. You see, it still wants to kind of miss a step. So I would recommend, and there's nothing wrong with that, it's simply trying to throw too much power at one time. So the stepper motor can't keep up. So you want to start with a lower RPM, and then just simply, once you turn it on, then just turn it up to where you need it to be, and it'll work just fine. Again, that's 325. And then we go back to our, in this case, is 40. But that wraps it up for that. Then just hit the power button, and once it de-energizes, everything will cut off like that, and you're good to go until next time. Now this, I've tested it. I ran this particular one, and I test every one, but I ran this particular one at 325 RPM for 8 hours nonstop. And then I measured the temperature at this NEMA 17 stepper motor, and it never did go over 94 degrees Fahrenheit, which again is well under that 170 degree threshold that they want you to stay within. And it will, this will run forever in either direction, nonstop, and you don't have to worry about it. You know, I like I said, I ran it for 8 hours at 325, 350 RPM. So I'll get into more detail in other videos as far as how I built the box. But of course, I have to keep some of that to myself, or everybody will be doing it themselves and not buying mine. But nonetheless, this will be sold through my website, billiardsinnovations.com, along with other parts and components and my machines and things like that. So, and yes, I have began selling, you know, rings and joint pins and butt caps and joint collars and joint protector pins and many other things, to include this dedicated standalone controller. I hope you found this interesting. If so, leave me some comments. If you have any questions, I am more than happy to answer, and I look forward to your comments and your thoughts on this box. Just let me know, guys. I'll see you guys soon. Thanks.